Hello guys, welcome to another video, and in this video I'm going to solve this problem of the day from Geeks for Geeks, lowest common ancestor in a BST. And as always, first of all I will be explaining the problem statement, then I will explain the approach, and then we will code it in C++ language. Let's get started. It is given here, we'll be given a binary search tree, means we will be given the root of a binary search tree, and in this binary search tree all the values are going to be unique. And additionally we'll be given two node values n1 and n2, and as all values are unique and they are not going to be equal, find the lowest common ancestor of the two nodes in the BST. And we have to find lowest common ancestor. Now, what is this lowest common ancestor? Let me explain you. Consider this binary tree which has root as 1, and 1 has two child 2 and 3, and in turn 2 has child as 4, then 5, and 3 has child 6, 7. Now if I ask you, which nodes are the ancestor of this node 4? 2 is ancestor, it comes above it, and 1 is also its ancestor, and it comes above the node which comes above it. So both are the ancestors. And if I ask you which is the common ancestor for 4 and 5, 5 also have ancestor as 2 and 1. So the common ancestor will be both 2 and 1. But which one will be the lowest, which comes first? While going upwards towards the root from both the nodes, when we meet at a node, that node is lowest common ancestor. And similarly, if I want to ask lowest common ancestor for these two nodes 5 and 7, let me go upwards from here. From 5 I will go to 2 and 1. I have reached the root node. I cannot go further. From 7 also I will try to reach root node. Here I have not got intersection of the two uh, two paths, but at root two paths intersect, so this is the common ancestor for both the nodes 5 and 7. So the approach behind solving this problem lies in this fact that if we go upwards from two nodes, wherever we are going to intersect, we will return that node. So the approach I am going to use here is that I will search for the values which are given to me, that are n1 and n2. I will search each node for these two values. I will search one. For example, let's say here values are given to me are 5 and 6. I will search. Hey root node, are you one of the values for which I am looking for? It will say no, it is containing 1. So I will make a left call, and again I will repeat the same process. I will check, hey node, are you containing the value for which I am looking for? No, it is containing 2 and I am looking for 5 and 6. Again it will make left call. So is it containing the values of 5 or 6? No, it is not. So I will make left and right call also from this node, but as its left and right child are null, so we'll be getting null and we'll return from here. Whenever I don't find the values n1 and n2, I will return null from that call. From its below I have not got anything, means at this node from its left subtree there is no contains either of these values 5 and 6, so I am returning null here. It means that 5 and 6 are not present in the left part. I will make right call and I will again check, are you containing 5 or 6? Yes, it is containing 5. Whenever I will find that node, either of the node n1 or n2, I will return that node. So from this call I am going to return node 5 to the node for which from which it has been called. and this node will check its left answer and right answer from the left call and right call. It has got null from the left and a node from the right call. Whenever it gets a null and a node, it will return that node which it has got from below. So in its turn, it will return 5. Remember, we made a path. Similarly, here from that path, this node will get upwards, and at certain point at lowest common ancestor, these both path from the other node also intersect. Now the left call has been completed, and left answer, I got the left answer for the root node as 5. So I will make here right call for the root node, and again I will check, are you one of the values 5 and 6? No, it is not. I will make its left call. Are you one of the values from 5 or 6? Yes, it is. So from here I will return 6, and I will make again right call from this node 3, and it is not going to contain any 5 and 6. It will return null. Now this node 3 has got 6 from the left and null from the right. Whenever a node gets answer as one of the answer as null, another as some value, it will return that node. It will return 6. And when a node gets null from both the sides, it will return null. Null indicates that it has not yet found 5 and 6, the n values n1 and n2. Here at this 1, its both left call and right call has brought some values. It means that its left call has got one of the values n1 and n2, and to its right call also got some value, as all the values are unique. So if one is 5, definitely other is going to be 6. So this is the lowest common ancestor, and at that particular node for which I find that it gets not null values from its left and right, this is the lowest common ancestor, and I will return that node itself. So this is the whole concept, and now I am going to code it with the same way as I have explained, so it will become more clear. It is going to be a recursive function, as we know that in binary tree problems, while making left and right call, we use recursion. Every recursion function will have some base case, so here I will write its base case. What will be its base case? Its base case will be if root is null. If root null means not of root, then I am going to return null. I have not got anything, so I will also return null. Now after that I will check one more base case, that if roots value and what is the name given to its value, it must be data. Yes, it is data. So I will write roots data, is it equal to n1 or its data is equals to n2. If either of the, here I will write roots data equal to, if either of the condition gets true, means I have found one of the values n1 and n2, and in this case I'm going to return root, as I have discussed here. Whenever I will find any value n1 and n2, I will return that value. So I have returned it. Now I will make recursive calls here, and my recursive calls are going to give me some value, so I'm going to store that it, and the recursive call is going to give me node star type of value, so I'm making here a node star type of variable. Let's name it left answer and make a recursive call to the left subtree of this binary tree, roots left, and I also pass the values n1 and 2 to this recursive call. Now similarly I will make make a call to the right part, and I will name it right answer. LCA root right n1 n2. Now I have answer of both the calls, and as I have discussed, I will check both answers. If both of them are null, so not of left answer and not of right answer, both are null at the same time, it means that I haven't found n1 and n2 till now, so I will return null here. In this case, haven't found in left side or in right side, I have not found n1 and n2, so I will return null. And I will again check. If this is not the case, both are not null, then maybe they both of them are holding some value, so I will check if left answer is holding some value as well as right answer is also holding some value. In this case, I will return that particular node on which I am currently present, as this node is only lowest common ancestor. Now if this is also not the case, both of them do not contain not null value, then it means that one of them is null and other is not null. So I will check if left answer is not null, then I will return left answer itself. As I have discussed here, from the node at which I will find this value, either n1 or n2, and I will return it, and at this node, if one is null, other is not null, I will return that not null value, so I am returning here left answer. Now again, if right answer is not null, I will return right answer. This is it, this is whole code, and this part is small calculation part of the recursive function. Now let's try to submit it. It is working for the given test case. Submitting it. Yes, all the test cases are passed successfully. It is working absolutely fine. Hope you understood the concept, and if you like this video, please press the like button and subscribe my channel. Thank you. Bye bye. Take care.